Hello, this is Dr. Keith Schubert, and this is my second video on integer division. In this video, we're just going to be covering examples, or an example specifically of division. So if you felt comfortable with how division is done in hardware from the last video, then you are safe to skip this one, because this one's just going to give another example. In this case, we're going to take a look at the example of taking 7 divided by 2. So 7 is 0, 1, 1, 1. We put that in low. High gets 0. And the divisor is 2, so we put 0, 0, 1, 0, 2 in binary into the divisor. So that's our setup of the problem that goes on. Remember, our steps are going to be, we're going to do this 4 times. So again, we have our 4 little sections here. So the first thing we're going to do is shift left logical high low. So the very leftmost bit of high will drop off. The next 3 bits shift over to the most significant. The leading 0 from low comes across. The next 3 bits of low shift left, and a 0 comes in because it's a logical shift. So that sets up our next spot, which is we're going to now do subtraction. We subtract 2 from 0 and we get negative 2. Now, since it is negative, we have to add the divisor back. So we have to add 2 to negative 2 to calculate 0. This is the whole idea that this was a restoring division process. Now, since it was negative, we don't set that bit. Remember that when we shifted that 0 that came in, that is the bit telling us, did it work, didn't it work? This is the quotient being calculated. Since it was negative, we don't change it to the 0 to a 1 because it didn't work. If this had been positive, then it would have meant that high was larger than divisor, and so there was actually something to remove off. In this case, it's negative, which means there was not enough in high in advance, so we have to record it as a 0. So then we shift again, checking to see if anything's in there. So the 0 shift over, the leading 1 comes over into high now, and the 2 remaining ones stay there. 0 comes in, and this is our guess of the next bit of the quotient. We subtract 2 from 1, and we get negative 1. This, of course, we don't change anything on low yet, but it is negative. Since it's negative, we have to add the divisor back to get back to our 1, and we do not change the least significant bit of low, the quotient. Now we'll shift again. So the next 1 comes across, everything shifts over, so now we have 3. So since we now have 3, when we subtract 2 from 3, we get 1. This is now positive. Since it's a positive number, we're going to keep it. We don't have to add the divisor back, but we do need to record that it was actually successful. So remember, we always guess 0, and we flip the bits when it really does actually work. We shift again. The final 1 comes across, and that 1 we just calculate shifts over, and this is our final guess for our least significant bit. We again guess it doesn't work. 3 is bigger than 2, so we expect this when we subtract it. 3 minus 2 gives us 1. It is positive. So we keep it, and now that least significant bit of low has to be flipped to a 1 because it was positive, it worked. So what we find out is that 7 divided by 2 is 3, remainder 1. 3 times 2 is 6, plus 1 is 7. So, yay, it works. And that's the end of our second example of how division works for integers on the MIPS system.